Hello friends, in today's question, a thin smooth rod of length L and mass m is rotating freely with angular speed omega naught about an axis perpendicular to the rod and passing through its center. Two beads of mass m and negligible size are at the center of the rod initially. The beads are free to slide along the rod. The angular speed of the system when the beads reach the opposite ends of the rod will be. So we have a rod which is free to rotate about its center with the angular velocity of omega naught, and it has two beads of mass m at the center initially. Let us suppose these are two beads which are at the center, and the length of the rod is given as L, and when the rod starts to rotate, these beads will try to move towards the end of the rod, one to the left, another to the right. So now one bead is here and another will be here. So the respective distance from the center will be L by 2, and the mass of the bead is given as small m. So this is bead 1, bead 2, bead 1 and bead 2. So let us call this as initial condition. And this is final condition, and now the angular velocity is let us suppose is omega, and the mass of the rod is given as capital M. Okay. So let us solve it for first initial condition. For initial condition, we have for rod, its length is capital L, mass is given as capital M, and angular speed is omega naught. And for the initial condition, the beads mass is small m each, and it is given that initially they are at center, and their size is negligible. So we know that moment of inertia of the rod about the axis at the center, through its center, and I suppose is given as I rod, which will be equal to 12 ml square. And since initially both the beads are exactly lying on the center axis, you can say since beads B1 and B2 are at the center, initially therefore their contribution to the moment of inertia is 0. Okay, and this is for initially only. Therefore we can say that initial angular momentum let us call that as L initial, will be equal to moment of inertia for the rod multiplied by omega naught, that's angular velocity. So we have this as 1/12 ml square multiplied by omega naught. Now let us consider the final condition. And in this condition the beads are at the end of the rod. The beads are at the ends of the rod. Therefore the moment of inertia of the system is going to change. Therefore the system, which consists of a rod plus beads, is going to change. And let us say the new moment of inertia, and we call this as I final, which will be equal to rod moment of inertia plus moment of inertia due to two beads, and the two beads will be at a distance of L/2 from the center. Moment of inertia due to two beads which are L/2 from the center. So let us call this as I bead. Therefore we can say our I bead will be equal to mass L square, L/2 whole square. So this will be m L square by 4. So we have two beads. You can say due to two beads, I B1 plus B2 will be equal to twice of ml square upon 4, which will be coming as ml square upon 2. Therefore we can write our I final moment inertia of final will be equal to moment of inertia of rod, that is 1/12 ml square plus I beads is our, sorry, here I made a mistake, this will be I B1 plus B2, okay, not I bead, and this will be our ml square upon 2. Therefore, the final angular momentum let us call that L final, and this will be equal to, we have L final is equal to moment inertia of final multiplied with angular velocity, which is taken as omega square. So not omega but omega, and we substitute value of I final, so we get L final will be equal to omega multiplied by 1.12 ml square plus small ml square divided by 2. So we know L initial, that's called equation number 1, and L final equation number 2. Now we are going to use conservation of momentum, angular momentum rather. Conservation of angular momentum. Conservation of angular momentum. L initial will be equal to L final. Will be equal to L final. Therefore, from equation 1 and 2, we get our L initial was 1 by 12 ml square multiplied by omega naught, and our L final was omega multiplied by 1.12 ml square plus small m L square upon 2. So therefore, we get the value of omega. You can say from omega is equal to 1 upon 12 ml square divided by 1 upon 12 ml square plus small ml square divided by 2 multiplied by omega naught. L square and L square cancels out, and we can say our omega will be equal to, this will be m omega naught 12, and we can take 12 as LCM. We get this is m plus 6m, and 12 and 12 also cancels out. So we get omega is equal to m omega naught divided by m plus 6 times small m. So this is the angular velocity of the system. This is the angular velocity of the system. Now here system means rod plus beads. Beads are both B1 plus B2. And from here we can say our option number D is the correct option. Option D is the correct. So you can say here option D is correct option. This completes the question. Thank you.